Hi, my name is Aman Chaudhary, and I'm a student of IIT Guwahati, pursuing my BSc degree in data science and AI. So today we'll be talking about my project, and that will be network intrusion detection system using machine learning. So in today's digital world, computer networks are constantly exposed to cyber attacks like unauthorized access and malicious activities. So traditionally, security systems are not enough to detect these advanced threats in real time. So in this project, I have used machine learning techniques to analyze network traffic and detect whether the activity is normal or malicious. And the main goal is to improve network security by identifying intrusions and reducing security risks. So moving forward, let's talk about the project objectives. Firstly, we have to detect malicious traffic. For that, we will use ML models to automatically identify and classify suspicious network activity in real time. And then we have identify DDoS patterns. We'll recognize the distributed denial of service attacks signatures within large-scale data sets. And then we will compare ML algorithms. And we have two ML algorithms for that. And then we will visualize performance. So here we have used a data set that contains a real world network traffic captures and including both normal behavior and simulated attack scenarios, making it ideal for training and evaluating intrusion detection models. So the key features will be packet information and flow duration, bytes transferred and protocol details, and communication behavior patterns. So the traffic labels we have benign, that will be the normal traffic, and DDoS, that will be malicious attacks. And let's talk about the technologies and tools used in this project. We have a Python for core programming language, and then we have a Pandas and NumPy for data manipulation, cleaning, and numerical computation. And then we have Matplotlib for graph generation, and then scikit-learn and XGBoost. These are the ML model training, evaluation, and optimized gradient boosting. And then we have joblib and GitHub for model persistence and version controlled collaboration. And there we have a picture of our project workflow. So let's see how the project works step by step. Firstly, we have to load the data set that will be CSV reading, and then we will clean the data, and then we will encode labels as it is a benign or DDoS. Then we will split data, and then we will train ML models. Like I have said, there are two models that will be random forest and XGBoost. And then we have predict the traffic, and then evaluate performance, and then generate the accuracy graph. And then we have to save the trained model so that we can use that in future to use it for different data sets, and it will be faster. And after that, we have our machine learning models that will be random forest and XGBoost. So in a random forest, we have features like it is a assemble method that builds multiple decision trees and aggregates their outputs for robust classification, such as high accuracy on tabular data, naturally reduces overfitting, handles features interactions as well. And then we have a XGBoost, which is optimized gradient boosting framework that sequentially corrects errors from previous trees for superior predictive performances. And there are some features like fast execution, high predictive power, built-in regulation and optimization. Then we have our system architecture here, in which we will go through the input process and then pre-processing. After that, we will go through ML training, and then we will receive our output. And if we talk about the results and the outputs, that will be, let's see what was generated. So firstly, we have a accuracy comparison graph, side-by-side performance of a random forest and XGBoost, which are two ML comparison models. And then we have a classification report, which will tell us a precision, recall, and F1 score for each class. Then we have a trained model, which is a serialized model ready for interface. So if you look at both the graphs coming on the screen, we can tell that both models have achieved high accuracy in benign traffic from DDoS attacks on the given data set. And we can also see that both the graphs are going to the value 1, which is almost similar. And we can say that both are performing very well, but that will not be same every time. And the values can differ for both models differently. But here we can see that the value is 1, so we can consider that both are performing well and equally. So after that, we will talk about the advantages and future scope of our project. So let's talk about the current advantages. We have the feature fast detection, in which our machine learning interface is significantly faster than a manual or rule-based monitoring. And then we have a high accuracy, as both models demonstrated strongly predict performance on real-world traffic data, as we have seen in the previous graph. And then we have a scalable, as architecture can be extended to handle larger data sets and additional attack type. As I have talked before, that we will save the data so that we can use different data sets, and it will be faster if we save that data. And there we have our future roadmap that says what possibilities that we can improve in this project in the coming time. So there will be real-time monitoring that will process the live network traffic analysis, and deep learning, which will used for complex pattern recognition, and then explainable AI, which will be used for analyzing the transparent attack classification. And there we have a cloud dashboard in which we will use a web-based UI for live visualization and alerting. And at the last, we have a conclusion for this project, and that will be that this project demonstrates that machine learning is a powerful and practical tool for modern cybersecurity. By applying a random forest and XGBoost to the given dataset, the system successfully classified network traffic and identified the malicious attacks with high accuracy, validating the potential of AI-driven intrusion detection. So let's see what problem has been solved with this project. So it's automated adaptive detection, replacing slow manual methods. And models validated in these projects are Random Forest and XGBoost. Both delivered strong results, as we have seen that both were giving highest accuracy. And path forward, we have a real-time deployment, deep learning, and cloud integration for this project. So that will be all for today. If you have any questions, you can type in the comment section. Thanks for watching. Have a good day. Bye.